Uh, Today we'll be doing our continuation of the binary tree, or the not binary tree, the tree data structure. So we're going to be doing a decision tree. So a decision tree is a tree whose nodes represent decision points and whose children represent the options available. The leaves of a decision tree represent the possible conclusions that might be drawn. So it's like a yes or a no kind of thing. So each node is like an option, yes or no. No's to the left, child, and yes is to the right, I believe. So we'll be using the same classes that we've already created. We're going to have to create a few classes. And then I also have in one of the other parts I'll have a decision tree that I created with it's different. We'll be shifting nodes around and stuff, and we'll be doing some rotations perhaps in the next couple videos as well. So we'll be using our array list class, array unordered list, the binary tree ADT, binary tree node, decision tree we're going to create. So if you haven't seen the video, see the previous videos. If you don't have those classes already, we're going to use our element not found exception empty collection exception class. There is a file to use for this class, so I don't use my GitHub very much, but I will upload the files that you need for this code, and I'll try to upload the code as well. If not, I'll just put the text file to use for the options. We'll use our linked binary tree, list ADT. We have a main, then my decision tree. We'll be doing that after. We're going to use a non-comparable element exception and an unordered list ADT, so this shouldn't take too long for the first part. Do I have this class up already? Decision tree, yes. So we're going to be creating a class called decision tree. Decision tree. So I'm using intellij. We'll right-click our src folder, and here I will input the class. So decision tree, DECISIONTRE, okay, .java, hit enter, and I don't think we will be using generics. Actually, we will be using generics, sorry. It's a public class decision tree of generic type T. We're going to have to import a few things. So we will be using input and output, but first we'll import java.util .star, the whole thing, and then we'll import java.io .star for the input output capabilities. Then here we can do a little doc here. We'll say the decision tree class uses the linked binary tree class to implement a binary decision tree. Tree elements are read from a given file, and then the decision tree can be evaluated based on user input. So I'll just move this to the left here. Based on user input, using the evaluate method. Evaluate method. So this is from the Java Foundations textbook by Lewis, and there's like two other authors, it's the 5th edition. I think the 4th edition is the same. My decision tree will be my code. This is their code. So we'll continue with that. So here we'll say we'll create a private variable, private linked binary tree of generic type string. Oops. So we have our class here. Then here we're going to create an object reference variable named tree. So I think it's excuse me, it stores the nodes in a list. Using inheritance, it calls a list. Is that an interface? Yeah, I think it is. And then it uses polymorphism, uses an array list to instantiate that. Using generic types. We may be using generic types within generic types. Hopefully we'll get through that and you'll understand. So here we'll say builds the decision tree based on the contents of the given file. So the file has like a few numbers and strings, that's it, and it just sets up to make the tree. So at param, file name, the name of the input file, and it throws a file not found exception if the input file is not found. So here we'll have public decision tree. We'll pass in string file name. So this is a constructor. So builds a decision tree. We can put here like constructor. So we're referencing the class name, it's a constructor where it's taking a file name and it throws IO exception. Actually no, it throws file not found exception. I think they might be doing it here a little different, but we'll go with it. If not, we can create our paths later if we need to. Because I don't think that way really works for me. I'm not sure how to do it exactly. Usually I just put the file somewhere and create the location and point it there. That works for me. I think you can. I tried putting it in my SRC folder in IntelliJ, it didn't work. But when I use Eclipse and did it that way, it did work. But either way, we can just write the path. Otherwise, Eclipse is just terrible. It keeps lagging all the time. You have to like disable your security using PowerShell. That's what I heard, to make it faster, and that's a real headache. So honestly, it's just use IntelliJ or VS Code. My opinion, IntelliJ is the best. VS Code's maybe better for like JavaScript or C. So we'll talk about that later. So we'll do file input file points to new file, and here we'll put file name. Then we'll say scanner scan points to new scanner. So we'll create a scanner and we'll pass in input file to scan. So scan equals new scanner. We're not putting system.in, we're saying okay, scan the file input file, which has the file somewhere. So here we'll say int number. Actually, I didn't even put the file on my desktop, so that's great. I think the video is going to stop when I do that, so I may have to make this 2 parts. So int number of nodes points to scan.nextInt. Then here we'll say scan.nextLine. Int root equals 0. int left and int right. Doesn't like that for some reason. Oops, I put the period there. So we have a scanner. We're talking about scanning the data from the file. Then we're saying, so it's gonna like scan, instead of user input from the keyboard, we're gonna scan from a file. We're gonna be using has next and next probably, and scan next line. There's a couple tricks we'll have to test or see, show you how it like gets the next space and stuff. So then here we're setting number of nodes to scan.nextInt. So I think there's like a number on that first line of the file. It's like 13 or something. That means there's like 13 nodes. Then it's like next, scan the next line. And then it's, so scan the next line, advances. So here it says scan.next line, advances the scanner past the current line and returns input that was skipped. This method returns the rest of the current line. So I'm not sure if it actually just goes to the front of the line or gets the whole next line. Anyways, we'll see. I forgot, I haven't done this code in a long time. I think it either gets the front, it's like, it ends the line at, so pretends there's a 13 here. And it's like, okay, we scan 13. Then on the next line, let's say there's like a string here. Whoops. Let's say there's like a string, right? So it's either going to just go to the front of the S, or it's going to get the whole next line. I think it just goes, I think if I remember correctly, it just goes to the front of the S. But we'll debug that and check what actually happens. Then we have our data here. These are just object reference variables. They're set to null at this point, and root set to 0. They might be set to 0 as well. We'll double check that. I think they are null at this point, but if it's an int, it might be 0. We can double check that. So here we'll instantiate a list. We'll say list of type linked binary tree. So list of type binary tree of type string. So it's saying, okay, we're gonna create a list here, and in that list we're gonna store linked binary tree nodes, and those binary tree nodes are holding strings. So that's all it's saying. Then it'll say nodes points to. They do in instantiation differently here. They kind of do it like this: java.util.ArrayList. You can do it however you want. This is just the way they did it. Then it's the same type, so linked binary tree of type string, and then remember the two angulars at the end. That's it, just like that. Make that a little bit smaller so it fits on one line. Don't need a space here. So we have our list. So here it's like, okay, here's the interface. So we're saying, okay, take the list. Using polymorphism, we're going to instantiate an array list. I think we could have just said array list here. No. 1, 2, new. I thought there was another way to do it. That's okay, we can just do it this way. So we'll say list of type. So all it says here's a list interface, and here's an array list which extends or implements the interface. So through interfaces we can use polymorphism. If array list implements the list interface, then we can use its super interface. We can use its super interface to instantiate polymorphism. And then so it's going to be like, okay, this list is going to store linked binary tree objects, storing string objects. So it's like, okay, we're going to store a linked binary tree objects, and those linked binary tree objects are going to store string objects. We're going to call our list nodes, and we're going to finish the instantiation. That's it. So you'll see our list is going to store linked binary trees, basically. And those trees are going to store strings. So after that, here we'll have a for loop. So we'll say, okay, for int I equals to 0, I is less than number of nodes, I plus plus, so number of nodes is like 13 or something. And I'll be like, okay, nodes dot add, so call the method add from the array list, I think. And they'll say, okay, add to index I, so I think it takes an index as a parameter. Does it? Yeah, see, it says, I don't know if you can see that, but it says int index. Then we'll say, okay, we'll instantiate a new linked binary tree of type string. And then scan dot next line. I forgot why they did the scan next line, but don't worry, we'll go through the debugger to test it out. Oh, I see what they're doing. Okay, so this is a parameter for the linked binary tree. So every linked binary, where's our class? I think we might be using that extra constructor that we didn't use before. Linked binary tree, what happened to it? This one. Constructor that takes an element. Oh, actually no, it's just taking one. So the element is going to be scan.nextLine, so that's going to be a string. So this is the kind of shortcut way to instantiate a node, or not a node, like instantiate an object. So we use that in the other class to add the binary tree nodes to the tree. But all it's saying is, okay, well, here's our linked binary tree. We're going to instantiate a new linked binary tree every time, right? So every time we're going to put a tree there. The way they do it, it's a little confusing because they're not using nodes. They're like, well, why are we creating so many trees, right? Well, that's just the way they did it. They're going to create parts of the tree and connect them all. So it's really a branch. But you'll see. The debugger, it does it, it explains it really well. So it's okay, it's like, okay, we're going to instantiate a new tree, a linked binary tree, and that linked binary tree is going to hold string objects. It's going to hold strings. And those strings, well, what's the string going to be for this, for index 0? So index 0, there's a tree here, and that tree's holding strings. Well, what's the element going to be? Because look, linked binary tree, the one that takes one parameter, takes an element. Well, what's that element going to be? What's the root going to point to? And all that stuff. If you don't know what the root is, we're going to go through it in the debugger. I recommend seeing the previous video where we create these classes and talk about all that, all these methods, and we actually create some linked binary trees. Well, we actually create linked binary search trees, but we use this class. So I recommend watching that first. So that's it. At this index 0, we're going to create we're going to instantiate a new tree, and that tree is going to hold strings, and the element's going to be in that text file. There's like a string there, and it's going to get that string. with scan.nextLine. Right, because you know when you create a scanner for user input, you're like scanner scan equals new scanner system.in, then you're like create a variable user input, so like string user input, then it's like system.out.println enter name or something, then you'll be like user input points to or equals scan.nextLine. It's going to wait for the input, but here we're going to take the input from the text file, so it's going to get the whole line, I believe. It's gonna show us in the debugger, so we'll go through that. Hopefully you understand so far. So here we'll use a while loop. While scan.hasNext. So it's going to say, okay, well, root points to scan.nextInt. So what it's going to do is going to be like, okay, well, I'm just going to go back for a sec. So it's going to add everything to the list. All the nodes, it's going to put them in the list. I don't know why they do it this way, they just do. But they're really putting a tree in each index of the list. So it's a little confusing. They're saying, okay, here's a list, and each index is going to store a tree. It's really part of the tree. Each index is storing a different part of the tree. Like index here is going to store a branch, the next one's going to store the next branch, the next one's going to store the next branch. Like the branch where it's like, it's a back pain analyzer. I don't know why they did it that way, but it's like, dude, did you sprain your knee or whatever, something like that. Yes or no, and each one's going to be like, it's going to be like a question. Did you sprain your knee? Did you fall down the stairs? Did you like jump off a building? Like something like that. So that's what it's doing. It's going to store all the nodes, all the decisions, all the branches basically into an index of the list. I think that's what it's going to do, if I can remember. And we'll say, okay, well, the root's going to be while scan.hasNext, so scan's going to, it's going to have something. So it's going to be like root points. We're going to see how scan moves in the debugger. I'm trying to picture where it is at this exact moment. It's going to be somewhere in the text file after we add the new link binary trees. I think maybe it's going to be on that last one that it added. Then I'll be like, okay, well, while scan has something, root points to scan. Okay, so okay, I know what they're going to do. I think I know what they're going to do. They're going to have after those strings below that, they're going to have numbers. Like they're going to have other numbers below that. Like here's like a 4, 5, a 6. Next one have like 7, 8, 9. The next one have like 10, 11, 12. So it's going to be like, while scanner has those integers below that line that it just grabbed, it's going to be like, okay, the root points to the next int below that line. Then it's going to be like left points to the next int below that line. It's a little confusing the way they do it, but I'll show you. So then here, what's wrong with that? Whoops, scan next int. So right point to scan.nextInt, and then scan is going to scan the next line again. And here we're going to have a setter. We're going to set the method. So we're going to say nodes. I guess there's a set method in the array list. So it'll be like nodes.set the root to a new linked binary tree of type string. Then pass in nodes.get root .get root element. How many brackets? No, I need parentheses here. Okay, so now we're going to use that constructor with three parameters. I believe that's what it's doing. So if you're not understanding what's happening, it's saying, okay, well, we're going to take a root that's going to be the element. Then it's going to be like, okay, we're going to set the linked binary tree. What is that parameter? Let's see if I can delete that, or whoops, cut that for a sec. Lagging out here. Alright, so I'll hit Control X. Okay, does it tell me what this method takes now? No, it does not. So I'll be like nodes.set. It's not telling me what it's taking. Here we go. Int index. Can I pull this up quickly on the Oracle docs on my other computer? So let's see, Java. Actually, no, what is this? Array list. And the set method might be overloaded, which probably is. Set. Here we go, set. So it just takes an element. So it says int index and e element. Replaces the element at the specified position in the list with the specified element. Okay, so we're setting the element here. So I'll just put is there a space? Oh, is there a space there? Yes, there was. So, okay, we'll put set method. We'll just put some notes here. So it'll be like set method or set, and it'll take an index here, and then here it'll take an element as parameter. So it takes an int index and an e element or t element. Then we'll say okay, or we'll say okay, this method replaces the element at the specified position in this list with the specified element. So we're going to replace the element at the specified position, so at index root in this case, with place the element at the specified position in the list with the specified element. So it's going to, what are we going to say here? Sorry, let me just pull my notes back up. So we have nodes.set root. We pass in root, so it's gonna set the index at the root. Then we're gonna set the position in the list. Okay, so it's like, okay, we're going to in this position. So at index root, we're going to create a new element, but this element is really an object because e can be an object, right? So we're going to create a new object here. We're going to store that in this position of the list. So we're going to instantiate a new linked binary tree, and this one's going to take this is they do it recursively too, so I don't know if we'll have time to do the whole thing. But what's happening here is now they're going to reset every index. So we're going to instantiate with the index, with the nodes that are lying somewhere else in the list, I believe. So we're going to say, okay, at index root, we're going to create a new linked binary tree of type string. Then we'll say, okay, we're going to pass in nodes.get root .get root element. Then we'll pass in nodes.get nodes.get left and nodes.get right. Okay, so what is that doing? So it's gonna be like okay, let's go to the constructor, and for the element, it's going to get the root. That's gonna be the element. It's gonna get the root element. There's a method chain here. Then for the left child, it's going to say, okay, well, nodes, which is nodes.get left. What is nodes again? Is that not the list? Okay, that is the list. So it's going to say nodes.get. Okay, so left is a, of course, so left is a index. So it gets the index and sets that as a child. Does the same thing for the right one. I think that's what's happening here. And don't worry, we'll debug it after, on top of the explanation I'm trying to do now. So after all that, it's going to keep doing that. It's going to set each index. And then after that, it'll say here, tree points to nodes.get root. Then we'll just move that bracket up here. Oh, that's it actually. So we have an evaluate method, a couple traversals, and we're done. And these methods are really small. So we're going to do that right now, and then I'll probably come back and test that with you in part 2. So after that, we'll say here follows the decision tree. Follows the decision tree based on user responses. So I don't know if we really need to traverse it, but we'll just do that anyways, because there's like different options you can do. You can like print all the nodes, or you can just choose a path, right? Does that make sense? You can choose a path like a story. Excuse me, you know, like if you're like born in the 90s. I'm not going to tell you what part of the 90s I'm born in, unless you check out my Facebook, but remember those like old school books where you like flip the page and it's like you choose an option, the next page does this, or if you go to that page then that happens. Basically that's what's happening here. So if you do, so each of those pages it's a node, right? But in this case we won't get through all the nodes if you choose a certain path. So that's what's going to happen. So at this part we'll say public void evaluate. Remember they used to have those like Captain Underpants books? And like, was that it? I think that was it. And you could like choose different parts of it. That was like way back in the day. So public void evaluate. And then with the brackets. And then here we'll have linked binary tree of type string. And then current points to tree. There's like another good one, but I can't forget. There were like some mystery books, but I can't forget what was the name. Maybe it was the Goosebumps choose your own story, but I can't remember, something like that. So here we'll have a linked binary tree of type string. So this is object reference variable. It points to tree. So linked binary tree of type string object current points. Okay, so they do this to it's really just to get the tree. So where is the tree? It's up here. It's kind of like a trick. This line, it's like a quick flip kind of trick. It just like gets the tree, basically. I think that's what it does. I can't see where we instand. Okay, here we go. So there's tree. Then here we, okay, so that's what it kind of does here. So tree points to nodes.getRoot, and I think at that node it's like storing the whole tree. Then it's like, okay, well here we're gonna do it again. So we're gonna say, okay, current points to that tree. Object reference variable, right? References or points to an object. And it's saying, okay, well point to the tree wherever it's stored now. The tree's been shifted around. So here was the first time it was shifted to an object reference variable. Now we're taking another object reference variable and pointing it to that one. So I hope that makes sense. And then we'll create a scanner scan here. So name scan equals new scanner. You can call it like keyboard if you're used to that or whatever. So system.in. Then we'll say while what's current again? Oh yeah, so it points to the tree. So while current.size is greater than 1, then we'll say system.out.println, and we'll say current.getRootElement. So if current.size, so if the tree.size is greater than 1, then print the print current.getRootElement. So print the tree.getRootElement basically. That's all it's saying. Then if scan.nextLine.equals ignore case. So if it equals to n, ignoring the capital and lowercase, then current, then here it's going to be like, okay, we're going to go left if it's n, so current points to current.getLeft. Then else, if it's not n, it's going to be y, so we'll say, okay, well then current points to current.getRight. So that's where it makes the choices, the decisions, for the decision tree. Then we'll have, then here we'll just print it out, so system.out.println current.getRootElement. We'll move that bracket up. We're almost done. We're going to be on heaps. Actually, we still have to do those rotations, but those aren't too bad. And then I also have another decision tree as well. We can do it for fun. Why not? So public void in order. So we're done now. These are the traversals. I think we've done these already. Or we're going to create some more traversals here. I think I was supposed to call them, but I was supposed to originally call them with the iterator. But I just kind of do it this way, so it works fine this way. We'll try to iterate through some stuff with the tree iterator after as well. So here we'll say public void in order t, so in order traversal. I want to check these notes to see if this is what they did exactly. So just give me a sec. I'm gonna pull up these notes from like my textbook if I can find it. What chapter was this? Do I have that still up? Okay, perfect. So we have the main method, which we haven't done yet. Just a couple lines. Evaluate. Okay, yeah, so I've added this. I don't know if they even gave it to us. I don't think they did. So I added this to the code. So it does work. I think you can use an iterator to do this. You can set it up to do it that way, but honestly, that's just extra, so this works fine. It's not like this doesn't work, it does work. So we'll just say binary tree node of type T, root, and then we'll have what takes an array unordered list. So see those videos if you haven't, to understand how to create those classes. If not, if you really want to, you can just create your own. You can create a new array list, whatever, it doesn't matter. Then we'll say here if root does not equal to null. We'll call it's a recursive method, so in order root dot get left, we'll pass that, and then nodes. What's nodes again? Nodes is global, is it not? Okay, sorry, so nodes is our array list. Should maybe just call it list. That's fine, so then we'll say nodes dot add to rear root dot get element. Then here we'll call an in order traversal again, and we'll say root dot get right. And nodes. Done. So you can do this with an iterator. Honestly, it's just an extra step. All it's saying is you create an it. We can try to do that if we have time, but all you really do is just create an iterator, like we did in the linked binary tree. Then you set this up like this, like with the iterator. Can we just use this one? Well, we didn't extend it, did we?